Welcome to my channel. Your tutor Mariam is here. It's the 57th video of Introductory Physics 1 and the 19th video. I'm going to talk about the laws of motion. That is the fifth subject of Introductory Physics 1. In this video, I'm going to solve an example about the net force. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So let's see what I have here. A traffic light has a weight of 120 newtons. It hangs from three different cables, T1, T2, and T3. T1 and T2 makes the angle of theta 1 and theta 2. If the force exceeds than 150, that cable gonna break down and the traffic light gonna fall. So what I need to do is see if the traffic light gonna remain hanging in this situation or the cable gonna break and the traffic light gonna fall down. To do so, I need to find the net force applying to the traffic light. So let me write down the net force applying to the traffic light. So let's say this gonna be my x-axis. That guy gonna be my y-axis. I'm gonna put the traffic light at the origin, and now I'm gonna write down the forces applying to the traffic light. Let's think about it this way. The traffic light is not moving, right? So there is no acceleration, there is no speed on the traffic light. So based on the second Newton's law, the net force is gonna be zero, right? So if traffic light doesn't move, that means the force right here, the net force right here gonna be zero. The net force to the x-axis gonna be zero, and the net force on the y-axis gonna be zero, right? So the way I want you guys to look at this problem is separating the x and y axis. Also, what I'm gonna do, I'm gonna separate it to different points. One point gonna be T3 and the other one gonna be on top right here. So it's gonna be 1 and 2. You will see why I'm doing that. So this is my traffic light right here, right? So T3 is gonna be upward, and then I have a force of the gravity. I'm gonna show it as W, right? So if you look at in 1, what I have as a net force gonna be T3 upward and then W downward, right? It's not moving in y direction, so the net force MA gonna be 0 because it's not moving, acceleration gonna be 0, right? So my T3 equal to W, right? And I already know that my W gonna be 120, right? My T3 gonna be 120, right? And then the tension was 150. So now I know, based on having the T3 right here, the traffic light not gonna fall down because T3 is less than 150, right? So I'm sure about T3 here. Now I need to find T1 and T2 and make sure they are less than 150, so then the traffic light won't fall down. Let me go back to this Cartesian axis. So I have T2 right here. That's going to be my T1, right? This is going to be my theta 1 and theta 2, correct? Let me break down the T2 in x and y axis. So my T2 right here going to be T2 cos theta 2. And then in y-axis is gonna be T2 sine theta 2, right? If you don't know how to break the vectors in x and y-axis, I explained it in the previous videos. I'm gonna put a link below. Feel free to check them out. Now let me break down T1. So T1 gonna do the same things. So that guy gonna be T1 sine theta 1, and here all have T1 cos theta 1, right? So that's gonna be theta 2, and this guy gonna be theta 1, right? My bad here. Now let's find T1 and T2. First I'm gonna write it in the x-axis. So in the x-axis, I have T2 cos theta 2 minus T1 cos theta 1, which is equal to 0, right? Because it's not moving in the x direction, and the acceleration is in x direction gonna be 0, right? The same things I did here. The acceleration gonna be 0, so net force gonna be 0, right? And then in y-axis, what I have is T1 sine theta 1 plus T2 sine theta 2. The reason is positive because I put the traffic light at the origin, and then these two forces have a direction upward, so these two forces gonna be positive. And then I also have weight applying to the object, right? W right here. So that's gonna be W, and it's gonna be negative. Again, it's not moving, so it's gonna be 0, right? So you will see in x and y axis equation, I have two unknown parameters, T1 and T2. The way you can solve this type of problems is like finding one unknown value from one equation and then substitute it in the other equation. Let me show you what I mean. So here I'm gonna find T1. So my T1 cos theta 1 gonna be equal to T2 cos theta 2, right? And then from here my T1 gonna be T2 cos theta 2 divided by cos theta 1, right? So now I have my T1. I can substitute right here. Alright, this is what I got from the previous slide. Now I'm gonna substitute T1 here. So this is gonna be 1, 2. I'm gonna substitute 1 in 2. If I do that, then that's gonna be T2 cos theta 2 divided by cos theta 1 times sine theta 1 plus T2 sine theta 2 minus W equal to 0, right? Let's substitute the value here. I don't know about T2 here, right? Cos theta 2 gonna be 30 divided by cos theta 1, so it's gonna be cos 60 times sine theta 1, which is gonna be 60 plus T2 sine 30 minus W, and I find it from the previous slide, that was 120, right? And that's going to be equal to 0. So if I do the little math, my T2 here gonna be 60 newtons. That's gonna be my T2. Now, since I have my T2 right here, I can calculate my T1, right? So let me substitute it here. My T1 gonna be equal to T2, which is 60 times cos 30 divided by cos 60, right? And that's going to be equal to 60 square root of 3. And this is my T1, right? So now I know the value of T1, T2, and T3, and they are all less than 150, right? So this guy is less than 150, and this guy also less than 150. So I'm sure that traffic light not gonna fall down because all of the force applying to this traffic light is less than 150. I hope you find this video helpful. If you like my video, hit the like button and I'll see you in the next video.